So the one done already, you don't need to mark your attendance later. Okay, so done. Okay, so regarding last week, which is the professional development week, right? So I asked you all to actually study this chapter 11. I mentioned in Telegram and also my times. Okay, let me record the session. Okay, so for this one, you have, I think, two questions come from this simple tutorial, one or two lah, okay? So please make sure you go through the tutorial 11. Then you can score for the question 1 and also the question 2 during your final exam. It is a very simple tutorial with a solution given. For example, like the transmitter, linear transmitter means they convert the signal from gallon per minute into the PSIG unit. So you have to see pneumatic transmitter. So they will mention, okay, for example, what is the input, what is the output. So please go through the examples, how to derive the linear equation, which is actually a straight line equation. So the y-axis here will always indicate the output, and the x-axis will indicate the input. So you are going to derive an equation to get the output relationship with the input lah. So this one is actually just a straight line. You are going to find the intercept and then form the straight line. So this is a very simple question in your final exam. Please make sure you can do. And I've included some different transmitter. So make sure you go through this one. And also, these are similar questions where you have to derive the linear equation using the straight line y equals to mx plus c. Okay, and then how to calculate the accuracy and precision. You better use the one I put here, standard deviation. So you have to go through yourself how to actually use your calculator, because the equations won't be provided for standard deviation, because your calculator can straight away give you the answer. You just change the mode to SD. Okay, please YouTube a bit, go through, Google a bit how to actually solve the standard deviation using the calculator. So don't use the equation to get the answer of this, but use your calculator. Okay, so I prefer you all use the standard deviation to get the answer. So this is the 0.0817 over, okay, over what? So if let's say full scale, then you have to base on the range, get the maximum value, just like this sentence given. Full scale is given. So based on the full, this will be the value. If a range is given, the front value is called 0. The maximum value is called the full scale. So go through this lecture 11 and tutorial 11. There will be questions for your final exam. I have mentioned this in the Telegram already, and I also mentioned in the My Times, I put it there. Please go through this chapter 11 and also tutorial 11, because they will be in your final exam. Okay, so the one you can skip for the final exam is actually the chart. So the chart actually include something like this question, but this one will be in your receipt. Okay, if you fail for your final, please remember I mentioned now, because I won't be here already after this week. So make sure you go through the chart, like the thermocouple calculations, if you fail your final. So if you are very confident for your final, you can skip all this, because I do not include all these thermocouple chart. So the one you need to focus for this tutorial 11 will be like, for example, question 1. Okay, and then question 1, you have to identify the input and the output. So you will actually do exactly the same like what I did. from here, what will be your input, what will be your output, then you plot the graph like this, you will actually find out this is actually a straight line equation. So you will form the y equals to mx plus c. So ym is here because it is a transmitter. So if it is a transmitter, then we are using the m stand for the measured variable. So this qm is actually the output stand for the measured variable. Okay, so how we put all the units in, please follow. Like this one is actually the slope. So the slope unit will be this one over this one. So these are similar questions you can go through. Exactly, I think just a different transmitter and then simple calculation to calculate accuracy. So I prefer you to use the standard deviation instead of using the range value. So use this value. Okay, so this one, please go through simple calculation to calculate the accuracy, standard deviation, mean value, what else? The average value, which means the mean value, everything like that. Okay, so, and then this one also very simple calculation. Please go through. A temperature transducer has a range of this one and this one. So this 20 will be named as the 0. And this value will be named as the full scale. Now you have a reading of 55 degrees Celsius. Compare the errors if the accuracy is 0.5% full scale. So this full scale meaning that you have to use this 250. You will be using 0.5%, okay, multiplied with this 250. What will be the value? Then you plus minus. Just like this 0.5 over the 100, multiply the full scale. So what is full scale? Full scale is based on the range given the biggest number. Okay, if 0.5%, then you divide by 100, multiply with full scale, you will get plus minus 1.25. If the reading is 55, then you plus minus 1.25. Then give the final answer, it will within this range. So this one, please go through very simple questions for you to score during your final exam. Make sure you go through the tutorial 11. Haha, how many times I repeat? Okay, so from there, this one also important, question 5. So this is the RTD, please go through. So you already know the first 2 questions will be chapter 11 for you to score for your final. And then the one I've mentioned earlier, for you to prepare for your final exam will be like heavy side. You remember we skipped the heavy side in the test. So now you have to include this revision covering the heavy side and then the Taylor series expansion, where you remember we have the non-linear term that we have to linearize them using the Taylor series expansion, not the one in your test. The one in your test is also approximation from a higher order to the lower order. That one also will be in your final as well. Okay, so, and then the second order dynamic behavior. So it's recorded, it's just a revision scopes. So please make sure you go through the second order dynamic behavior, just like the test question, very similar. Like you have to make sure you convert the last term into 1, and then you calculate the overshoot, damping factor, time constant. The solution also already posted to my times. If you fail for your test 1, or you actually get half out of I think we convert to 10 marks, right? So if let's say you actually having, I think total is 30. Okay, I can't remember lah. So if you score half and below, you have to make sure you have to go through the questions again of your test 1, so that you can do for the second order dynamic behavior. And then also for the Simulink, that one also will be included in your final exam. We'll talk more about final exam later on at 6 o'clock. So the beginning of this lecture session, I need to brief you all about this lecture 11 and tutorial 11. They are very important. Please make sure you all go through this and you all know how to use the calculator to perform the calculation, like to get the standard deviation, the mean, and so on. Okay, so this is all about the lecture 11 and tutorial 11. They will be in your final exam. Please don't skip. Okay, so and the scope of the final exam I have briefed just now briefly. Okay, tell you all the scope of final exam. We will talk more about the final exam later at 6 o'clock. Okay, so now we go back to our lecture 7. Okay, so this lecture 7, we will introduce what is block diagram, and don't forget about your assignment. Your assignment actually having the group and individual components. The submission actually very close to each other. One is 11, one is 12, right? So make sure you already start your assignments, both assignment 1 and 2. Okay, so this chapter will introduce the block diagram in series, parallel, and feedback form. We will learn there are 2 parts actually for this block diagram reduction, meaning that they give you few blocks, how you finally simplify using an equation to represent these few blocks. So introduction of block diagram, they will be in series, parallel, and feedback form. The one in your assignment is actually the feedback form. Combine block diagram, then finally you will be having the closed loop transfer function. What is closed loop transfer function? Closed loop transfer function is the end of the signal over the initial signal, the whole system. Simplified block diagram is a block diagram reduction, or the other one we call as the canonical form, which means you'll be having a block on the top, go to the end, which is your output, then this is your input. You'll be having something going back, and this is the summation block. If let's say this is negative, then we call this as a negative feedback. So we will be having a block on the top and a block at the bottom. We call this as a canonical form. Okay, so this is the one we have, canonical form. So y over the x, this one we call as a closed loop transfer function. So closed loop transfer function. Okay, we'll be introducing how to actually simplify the block diagram. But before that, you need to understand for the block we already have your Simulink classes already. You actually drag and drop the block onto your Simulink window. So this is the transfer function block. We have this output over the input. So this one is the transfer function. R, sometimes they do not use the letter R to indicate the input. So you have to read the question. Sometimes they use the X. So sometimes they use the X to indicate the input. Sometimes they use the R to indicate the input. So we have the signals. Signals means input signal, the one going into the block, and the one leaving the block we call as the output signal. So this is the input signal, and this is the output signal. Okay, so transfer function for GS will be CS over RS. So you can see all the equation actually in S response. Transfer function in S response. So this one is as a function of S in S response. So output over the input will be your transfer function. So this one stands for your transfer function. Okay, then we have learned this is a summing junction. If you have this one in your Simulink classes, remember you double click or you right click, you can change the default having 2 signals going in, the plus addition block. You can actually click and change to the number of signals you want. For example, you have the 1, 2, 3 signals going in, then you'll be having, for example, this one is plus, plus, minus. So plus, plus, minus, you can change in your Simulink. Okay, so from here, you have R1, so plus R2 minus R3. Remember the straight line over here always indicate the equal. So equal the output CS. So peak off point is the one that we have learned previously as well. Remember this one turning back. If this one is YS, this is the one we call as the peak off point, where the signal will be equivalent. Okay, if you have another signal going back here, also YS, something like this. Okay, same go to this one. Peak off point is 1. So it will be the same signal RS, 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 RS. So if let's say I have this, I have this. So this one A, this one A, this one A. So this is the peak off, or we call as the tag off point. They will be same signals. Okay. So block diagram in series form means side by side. So if side by side, you remember they can be multiplied together to simplify. Just like this one, we will be having the first one. Okay, G1 transfer function will be output over input. Second one will be G2. Output of the G2 is C, input of the G2 is M. Okay, so now you want to get the transfer function of the overall system. So it will be output, final output C, the input E, equivalent to multiplication of these two blocks. So G1 multiplied with G2. So what is your G1? Your G1 is M over the E multiplied with C over the M. So this one will give you this answer. So I crossed that wrong one. So from here, you will get back the C over the E. So when you have the series, means you can multiply them together to simplify them into become this form. So meaning that you'll be having this one combined together, G1, G2, the one going in will be E, the one going out will be C. So if you have 3, so this one, let's say it is R, this one, let's say it is Y, so G1, G2, G3. So you can simplify into one single block. Your output is Y, your input is R, then here will be G1, G2, G3. So this is multiplication. Okay, and the transfer function of this overall system will be called as the Y over the R. So Y over the R equals G3. Like this one, C over the E equivalent to G1, G2. So this is the one we call as a series. Series means side by side. If side by side, then you can multiply them together to become G1, G2. The input will be the same, E, the output will be the same, C. So the transfer function will be C over the E equal to G1 multiplied with G2. C over the E, like this one, equivalent to G1 multiplied G2. Okay, block diagram in series form. So this one also the same thing. You'll be having C over the R equivalent to G1, G2, G3. Or you have the complete, you just put the bracket S, then the rest also have to include the bracket S. The S in bracket lah. Okay, so this is series. You just multiply them together. So they are in series. You can simplify them to become one single block. Okay, so you will multiply G1, G2, and G3 into the single block. Then the input will be RS, the output will be the CS. So this one is the series. How about parallel? So if let's say it is parallel, it is just like your maths, you plus them together. So from here, you'll be having G1 plus G2. So here, if you simplify, it will be G1 plus G2. Okay, parallel subsystem has a common input and an output formed by the algebraic sum, means you just have to sum them out of the output from all the subsystem. So examples, okay, you'll be having this G1, G2, G3. When you're having the addition block over here, we call this parallel. So all these three you can plus together. So G1 plus G2 plus G3 to become one single block. And then the one going in is R, the one going out is C. The equivalent transfer function, which is a simplified block, will be E stand for the equivalent. So to simplify, your GE equivalent equals to C over the R equals to G1 plus G2 plus G3. So why they have plus minus? Because it is indicated over here, they use plus minus. So you just follow plus minus, including this one price plus minus. So in your exam, it will be always indicate, it will indicate clearly, for example, plus, minus, or it won't be like plus minus over there. It is either plus or either minus. So the notes over here, you can put C over the R equivalent to G1 plus G2. So this one is parallel. You just have to sum. Parallel, how you check it is parallel? There will be summation block. So this one will be the summation block. You will see the signals going in. Okay, so this one is parallel block. So you have to plus A, B equals to C, something like that. A plus B equals to C. So sum them up, sum. Okay, next. Some introduction also, block diagram allowed and not allowed. Okay, example, allowed means we can only have one signal going in and one signal going out. It cannot be two signals going in or two signals going out. So if you want to have the definition, like for example, it's actually x1 plus x2 go inside the GS, then you have to use the sum block. You cannot have two signals straight away going in into a block. Okay, you have to change into something like you use the sum block, this one summative or addition block, or we call the add block, to combine two signals. For example, this one. So this one is not allowed. It is because of cannot have two signals going in without the add block. Okay, same goes to this one. We cannot have two signals going out without the summation block, the add block. Okay, so this one is the one we call as the pick off, or we call as the tag off point. So if take off point means you have this one x1, right? So this one will equals to a x1, this one will equals to a x1. They are all the same. Means your x1 equals to x2 equals to x3. They are all the same. Same signals for take off and pick off point. Okay, so this one is not allowed because they have different meaning. So if let's say you want to use this, then you have to use the take off and pick off point. So this one is plus, right? Let's say if it is not indicated over here, by default, it will be plus plus. So this one's supposed to be x1 plus x2 equals to x3. So this is wrong. Okay. If you want to have multiplication together, it will be having this one, something like this, x1, x2, side by side. Okay. And this one will equals to something I can't draw because it is wrong. So if it is side by side, then it will be x1, x2. Definitely this and this not equivalent. They are not the same. Because of you'll be having this one defined as plus. So x1 plus x2 equal x3. The answer given is not the same. Okay, now we're having example to solve. Make sure you can solve this one together. So determine the transfer function of ys over the ss for the block diagram shown in figure 3. Where's the answer? They do not give an answer. I think I include this one in the tutorial. So we will discuss this in the tutorial where we actually have to put the signals on all the signals like the alphabet A, B, C on all the signals over here. So for example, this one is a pick off point, right? So this one you will be having the X. So this one also X. And this one also called as the pick off and take off point. Then you'll be having the Y over here, the Y also over here. Okay, then the rest of it you will place the signal A, B, and then C, and then D, and so on. Okay, then you will start everything from the back. What is your GC? Your GC is output Y over the input D. Okay, so what is your Y? You will finally having your equation determine Y over the X. So you'll be arranging your Y equivalent to GC multiplied with the D. So this D is the one you have created just now. You have to replace them. So what is your D over here? Your D is, this one is plus, right? So you'll be having C plus X equals to D. So GC multiplied with C plus X. Then you already replace the D. So C also something you have created. The one originally provided in the question will be X, and then Y and all the transfer function. So from here, you can remain the Y don't touch, GC don't touch, X don't touch. So from here, you have to replace the C again. So what is your C? So you start from the back, you go from the back to the front. So what is your C here? You can use the transfer function block GB equivalent to output over the input. So C over the B. So GC multiplied with, then you rearrange, you will get the C equals to GBB. So GB multiply with the B to replace the C, then plus the X, don't touch. So now replace the B. So what is your B here? Your B is, the one going in is A minus Y equals to B. So A is plus minus the Y equals to B. Then you replace the B here, will be GC multiplied with GB multiplied with the B equivalent to A minus as Y. Then the whole thing, a bracket, then big bracket to indicate. So plus X. So you will finally replace the A as well. So what is your A? Your A here is GA will be output over the input. So your A will be GAX. So GC multiplied with GB. Then this one is GA dot X minus Y. Then plus the X. Okay. So this one is your Y. Finally, you will do the expansion, this one, and rearrange. So we will cover few questions. I just gave you some introduction. So the first step is you have to check pick off or tap off point. So like this one, the one I highlight here, means the signals will be the same. Okay, and the Y over here also the same for the top will be Y. Then the rest of the signals, the output and the input signals, you have to name ABC. So like A, B, C, D, and so on. So you will start from the back. The first block is GC. It will be output Y over the D. Okay, then you rearrange to get your output at the left-hand side, because finally you will get something Y over the X. So what is Y over the X? The Y over the X is closed loop transfer function. So we'll have few more examples later at 6 o'clock. So this one is just introduction. Give you some idea how we solve or simplify the block diagram. Okay. The one very similar with your assignment, where we call as the feedback block feedback form, is you having one forward and one backward. So the one go to the from the input signals towards the end of the signal is your output. Okay, then from this output it is feedback to the input again. So we have actually the shortcut equation to derive without using all these fundamentals. For example, closed loop transfer function will be output over the input. So output is this one, and this is your input. So based on here, you can use the equation that top, so you'll be equal, this one it will be in fraction. The top only having one G1. Okay, you'll be simplify all the blocks for the top pathway, the top, and this one is the bottom. Okay, so from here, top already settled, you'll be having the equation of 1. If this is minus plus, it will reverse the sign to become plus minus. Let's say this is minus, then you will get the answer of this one is plus. If this is plus, then here will be minus. So it will be reversed. So this one reverse. Minus plus, this one plus minus. So you can put a note there. The signal will be reversed. Okay, so I will, so you can link better this one and this one, reverse. Okay, and then you'll be having the one come from the top all the way to the end of the signal. You're only having one block, so it is G1 multiplied with the one at the bottom here. So you only have one block, G2. So one more example, maybe we having 2 blocks on the top, so G1, G2. Okay, then this one is your final Y. Then here also G3, G4. Then the one going in, if let's say this is minus, this is plus, so go back here, and the input here, let's say I'm using the X. So you'll be having Y over the X. We call this as a feedback. Feedback form means from the beginning go to the end, then feedback go to the beginning signal again. So this one, the shortcut will be you focus what are the blocks on the top, you simplify. Like this one, it is in series, so side by side you can multiply them together, G1, G2. So let's say this is 1, this is 2. So G1, G2, then done already. So this one is the top over the 1, and this is minus, so it will become plus. Okay, and then you'll be having the top multiplied with the bottom. So you'll be having G1, G2, which is the top over 1 plus. Top means you repeat this one. So G1, G2 multiplied with the bottom one. This one also side by side. So this one we call as the bottom, and this one we call as the top. So the bottom will be G3 multiplied with G4. So this is the shortcut. So it is simplified as we will be having the top over the 1, then reverse the signal of this one, and then the top and bottom multiplied together. So this is the feedback form. So closed loop transfer function, it is the output of the signal over the input of the signal. So this one called as a closed loop transfer function. Okay, so in this particular example, it is the C over the R. So this one is called as the closed loop transfer function. So closed loop transfer function for more complicated block diagram can be written in the general form, where we have this one over 1 plus. We call Z is the output, Zi is the input. So pi f means it is all the blocks actually on the top, we call as the forward path. Okay, forward path from the beginning of the signal until the end of the signal. So we have the G1 and G2, your forward path having this G1, G2. Then over the product of the forward path blocks, which means the top blocks, multiplied with the bottom blocks. So the bottom blocks they call as the product for every transfer function in the closed loop system. So everything in the closed loop system means this one, this one, this one, this one. Okay, so this one is the feedback shortcut where we do not need to actually include the signals from the beginning, from the end of the block. You do the calculation towards the front and rearrange to get the output or input. No, you can straight away use the shortcut. So the shortcut will be all the block of tops over, then 1. This one reverse the signal. If plus, then become minus. Then multiply all the block. Like this one is G1 and G2. Top and bottom multiply them together. So this is the shortcut closed loop transfer function for the feedback block. Okay, so example 3. So this example 3, okay, we will target this every time you can focus on the feedback block. So feedback block means you have block going towards the end, and then some of the signal going feedback to the front part, just like the one I circle over here. So to simplify this one, you finally will become GR over 1, and this is plus, it becomes minus. Then everything in this block will be GR multiplied with GH2. So this is the feedback block. So you'll be having the forward, or we call it the forward path, or we call it the top. All the blocks from here to here, you only have one block. Then feedback, you will be having this and you'll be having it. So this one is all the block in the closed loop. And minus is because of you reverse the signal. Reverse the plus to minus. So that's why you will get this plus, and then you will get this minus. Change the color. So this one minus. Okay, so this part already done. So if you simplify, you'll be getting You copy again this one, you'll be having this block GH1. The one going in will be T0S. So this whole thing already simplified to become this block. So GR over 1 minus GR GH2, and the output is T4. So you already simplified the one I circled over here into one single block, which is this one. So you'll be having this one substitute over here. So now you having this side by side. Further simplified, you're getting your output, which is T4 over the T0, okay, as a function of SS, of course. Okay, so this one is in series, so multiplied. You'll be having GH1 multiplied with all this GR over 1 minus GR GH2. So this one multiplied. Then you will be getting this answer exactly the same. Okay? Now it doesn't matter because product sometimes A multiplied with B exactly the same like B multiplied with the A. So the arrangement of this one you can change. Like you can put GR multiplied with GH1, you will get the same answer. So this is positive feedback. Why positive? Okay. Positive is when the feedback here is positive. Just like this one. So this is positive feedback. Okay. So positive feedback. Okay, negative feedback means this one is negative. The feedback is negative, that's why it is named as the negative feedback form. So how to simplify this? You will simplify the simple one first, the one side by side. So these two will be combined together to become G2, G3. Same goes to this one, will be combined together, become H1 multiplied with H2. Okay, so you will sketch the block like this one is G1, the one going is R. You can have this, or you can just write R. So this one is easier. Just standardize everything. If you put the R, then you don't need to put the bracket of S. So just use this one is fine. Just like inside, I do not put the S anymore because I already removed the S. Because we know in the block diagram, everything will be in their transfer function, which is in S response. So here going in, copy here is minus. So the one not, if I do not write anything in final, means this one is plus. Like this one, they actually indicate it is plus. Okay, and then you already simplified this one into one single block. So G2, G3, then go to the end, this is your C. Then feedback, you also simplify this one into one single block, H1, H2. Then you go back here. So this is another feedback block that you can simplify this one into G2, G3 over 1 plus all the block inside this closed loop means G2, G3, H1, H2. We will always write the feedback block here at the back. So we will write this one, put at the back. Okay, forward block will be placed first, and then only followed by the feedback block. So this is the shortcut of the feedback loop where we have the forward G2, G3 over, because this is minus, then you'll be having a plus over here, the reverse sign. Then everything in the closed loop block, we will place the forward blocks first here, and then multiply with the feedback. So this one, in your final exam, maybe you can just put a block over there so it can save your time. Then you can continue to solve all the unsolved block so that you can solve step by step. So this one is R. Then finally here is your C. So this one is side by side again, right? So finally we get your C over the R equivalent to G1 multiplied with all of this. So this will be the answer. Okay, G2, G3 over 1 plus G2, G3, H1, H2. Okay, you can put the bracket S, or you can just solve the answer in this form. Okay, this is not a simplified one. So in this case, you just, okay, make it longer. Then you'll be having a fraction on the top. the numerator and denominator because this is a transfer function. So C over the R stand for the closed loop transfer function. We will have more examples to go through at 6 o'clock. Okay, now canonical form. Canonical form means you'll be only finally having a block on the top and a block. So a block on the top means the forward pathway and then a block at the end. So this one you don't need to simplify further to get the C over the R because the question only requires you to get canonical form. So canonical form is not, you don't need to solve further. If you want to solve further until you get the final answer, should be C over the R equivalent to all these I name as the A This one I name as a B. So it will be A over 1, this is minus, plus A multiplied with the B. If you do not have sufficient time during your final, you actually can represent something like this. So you don't need to copy the whole thing here. Okay, but if you have time, please make it a complete answer This one is just like in case emergency, don't have time to copy all, but you know the final answer. You can just represent all this equals to A, this one equals to B, therefore you have this answer, and so on. Okay, so this is the final answer we call as the closed loop transfer function. But if the question asks you, okay, sufficient to solve until you get the canonical form, then you just present your answer in the form of a sketch block like this. The top having one block, the bottom having one block. So this is the one we call as the canonical form. Canonical form. Okay, so we will have this question step by step solve. So we will focus on the one easy to solve, just like you can circle this. This is the feedback block. It can be solved into one single block to be G1, G4 over 1. This is plus, then it becomes minus. Everything in the block. So 1, 2, 3. So it will be G1, G4, H1. Then you already simplified this block. Same goes to this we call as the parallel. So this parallel block means sum them up. Sum them up. You'll be having G3 plus G2. Okay, so combine all the series. The first step, actually, if you can have this, you actually combine the series block already So G1, G4 is their series block. Same goes to combine all the parallel blocks. So this one parallel, you'll be having a add block. So this one is add block. So don't get confused the add block with this add block. There must be signals both going in. Okay, then there are two signals going in. Just like this one, I can consider this one as a add block because I have the R minus the signal over here, something like that. So you simplify this, you'll be getting the answer of G2 plus the G3 or G3 plus the G2, the same thing, just like this. Okay, so this is the feedback block that I have simplified just now already. You'll be having this forward path, forward over this one because of plus, then you change to minus. Okay, and then this one is all the blocks. So all the blocks mean all these, multiply them together. G1, G4, H1. We will always place the H1 at the back. We won't arrange the feedback block at the front. So remember to put this one at the back. So all the blocks mean G1, G4, H1. So then sketch to get just now the feedback block and also the parallel block. So now this one is side by side, right? So multiply them together. So you don't need to do the expansion, you just combine them like this whole thing, G1, G4 over 1 minus G1, G4, H1. You combine G2 plus G3. So you just extend this line to become bigger. So like this one. So this is series. You combine them to get the answer of this. Okay, finally, this one don't need to simplify into closed loop transfer function because they ask for canonical form. So canonical form means finally you'll be having one block on the top and one block at the bottom. So this is canonical form. Okay, so it is a very quick one. We have more examples at 6 o'clock. So let me have one more. Then we go for a break, come back for the scenario question. Okay, so standard block diagram of a feedback control system. I will link this one maybe to your lab practical so that you can visualize this. So standard block, okay, so this one. Okay, so your process, how you get your GP. This is about your assignment one. Let's say I'm having level H. Okay, my output is H. I'm having a sensor to measure. So I'm having a sensor to measure the level H. Okay, then you'll be having the controller GC lah. So sensor means GM. So the whole thing here is actually your transfer function for GP. You have to derive the equation of the GP using the mass balance, unsteady state minus steady state, and so on. So your controller, remember, you key in the value of the set point, HSP, the set point of the level. The controller will compare the set point and the measured variable, which is the HM. So this one is the HM, means measured variable of level. So we'll put the subscript M over there to indicate the signal already changed, maybe from cm to milliampere, example. Then from there, your controller will ask the valve to do something. Valve is your final control element and the transfer function is GB. Okay, so your valve will control something to go in, for example, the flow rate. Okay, so finally you can bring this level back to the or closer to the set point of HSP. So this is negative feedback. So we introduce what is negative feedback. Negative feedback means you want this H closer to set point. So this means the definition of negative feedback. The corrective action means you will adjust the flow rate of this one so that you can regulate, you can control the level of the H closer to the set point of this one. Then we can name this as a negative feedback. So in a standard or typical negative feedback system, we'll be having a process where you have to derive the GP. So let's say here you have so here you'll be having a valve, control valve, we will always put like this. So this is the actuator. So remember, we have the equation how to derive the GP. We'll start from unsteady state, mass balance. So let's say this is the QI and the one going in is the Q2 example. And here maybe we have the pump. Okay, we have the pump over here. Then we have the valve over here. Then you will be having the equation by default, the H over the R. Okay, so let's say this one is Q3. So unsteady state mass balance is mass dot in minus mass dot out, equivalent to dm over dt. So expand the m equals to rho v d, right? Then because rho equals to m per v, your m equals to rho v dt. So expand the equation will be density multiplied with all the in Qi plus the other in Q2 minus rho, the exit will be Q3. Okay, so expand the V, you will get density is constant, so you will factorize outside. The A also constant, dH over dt. We have derived this one many times already, so rho Qi plus rho Q2 minus rho H over the R. Use this simple example to relate what you have learned previously. So you cancel all the density, you'll be having A dH over dt equivalent to Qi plus Q2 minus H over the R. So what you need to do now is you'll be having equation 1 for your unsteady state. Your steady state will be just include the subscript of S to indicate it is the steady state value. So this one equation 2. Then you use the equation 1 minus equation 2 and introduce deviation variable. So from here, we're having ADH minus HS over dt equivalent to QI minus QIS plus Q2 minus Q2S minus H minus HS over the R. Okay, introduce the deviation form, for example, H equivalent to H minus HS, QI equivalent to Q minus QI, S, Q2 equivalent to Q2 minus Q2S. So simplify this one to ADH over dt equivalent to QI plus Q2 minus H over the R. Okay, then Laplace transform both sides. So Laplace transform both sides means you'll be having ASHS minus H0 bracket equivalent to QIS, Q2S minus HS over the R. Okay, for the transfer function, you remember we do not have the initial condition. So you'll be having ASHS plus HS over the R equivalent to QIS plus Q2S. So factorize your output. You'll be having AS plus 1 over the R equivalent to 2 inputs, QIS minus Q2S. Okay, then you'll be having HS. This will be ARS plus 1 over the R. So copy lah, huh? So from here, you'll be having your output equivalent to, this is your input, so you will place outside. You'll be having R. When you move to the other side, it will be 1 over, because this is multiplied, so you'll be having ARS plus 1 over the R, then QIS. Minus the same thing, 1 over, or you reverse the signal, like R over ARS plus 1. Okay, R over ARS plus 1, then the input Q2S. Okay, remember to check which one is having the control valve. So the control valve is the one Q2, so your GP. So now separate into 2 equations, GP and GD. Your GP will be output over the one having the control valve, which is this one. So this one should be plus. So just now we have 2 input going in, plus, so this one is plus. So output over the input, Q2. It is because of this one having control valve. You adjust this, which this one is actually the manipulated variable. The one you cannot adjust is your QI. So you look at the diagram, simple diagram over here. This is the disturbance. So this is categorized as disturbance. So this one is categorized as your manipulated variable. So over your manipulated variable, you will get your process transfer function. So this one we call as the process transfer function. We have one example early on. I think about the tank, not about the level. I can't remember already. I think similar question. So this is just a recap. So output over the input which have no control valve. So QI. So this one will be R over ARS plus 1. This one also R over ARS plus 1. So this is how we derive the transfer function of the process. And this is the disturbance transfer function. Okay. We derive based on the transfer function method where we use the unsteady state minus the steady state. So once you got your GP and GD already, this is a typical feedback block where we have the transfer function of the process plus together disturbance transfer function. So transfer function, the input of your GP, for example, here is the flow rate, the input to here. The output here, what is your output? It is your Y, which is the level. Okay, then you'll be having your disturbance. This is the input of the disturbance going in. So these two plus together. So you measure the Y using the transmitter. So you can link better with the diagram over here. You measure with a transmitter. Okay, why going back? Because you want to compare with the controller set point. Okay, set point. So the controller will ask the valve to either open bigger or make it smaller to reduce or increase the flow. So this one is your valve. Okay, final control element to finally adjust something which is your manipulator variable. So this is the feedback block. Standard block diagram of a feedback control system. I have one example to relate, and I derived the GP and GD. So this one we always sometimes I think in final exam I do not having this one at the front. Okay, so everything going in will be just YSP. So this one can be simplified into YSP. Straight away it will be your GC, and this one going in something like this. So I do not have another transmitter over here, so it is ignored during a final exam. So in the tutorial and lecture, I include back lah. So we have a 5 minutes break, then we come back. We will having one example. So this one is the feedback block. You can simplify it using the shortcut. Don't need to use this method. So this shortcut can be, we have the set point change. Set point change means, okay, we have two. So set point change and disturbance change. Set point change means output over the input YSP, output over the disturbance. Right. This one over this will give you the set point change based on the set point. It is a closed loop transfer function based on the set point change. So this one is the closed loop transfer function based on the disturbance change. So Y over D. So there are two signals going in. One is YSP, one is the D. So you'll be having two transfer function, Y over the D and Y over the YSP. So if Y over the set point, SP stands for set point. You call this as a transfer function. So transfer function based on set point change. This one also transfer function based on disturbance change. To be complete, it will be closed loop transfer function. Closed loop transfer function. Okay, so to simplify, okay, if let's say this is a set point change, we will cover this part. Ignore this is not there if there's set point change. So you'll be having all the forward path GC, GV, GP over everything over here. And then side by side with this KM to get this answer. So you'll be having GC, GV, GP over 1. This is minus, so become plus. Then everything in the closed loop. So GC, GV, GP, GM. And remember here got side by side KM. So that's why series, multiply them together. This is Y over SP. If Y over the D, the same thing. From the top, you're only having GD from the beginning until the end. So this is GD over, okay, everything in the feedback block. So it's GC, GV, GP, GM. So this one will be Y over the D. So if you use Y over the D, it will be GD. Only one signal on the top, starting from the signal, go to the end. So this one is GD. Then over everything in the feedback block is, what is feedback block? Feedback block is this one. Closed loop. So we're having this exactly the same like the set point change. So GC, GB, GP, GM. So 1. This is minus, so this is plus. GC, GV, GP, GM for your disturbance change. So we break for 5 minutes. So don't use this fundamental, but use the shortcut. So Y over the D is from beginning. So use the highlight from beginning until the end. You're only having GD. So that's why the GD is here. And then from the feedback block, start from here all the way from everything inside the loop. The pink color is this one. And then this one minus. That's why this one plus. Okay, so this is minus become plus. Okay, so we have derived two equations, one for the set point change, one for the disturbance change. So we'll be having example scenario question, which is the last part of today, example 6 after the break. Okay, so the one haven't marked your attendance, please mark your attendance now. Then we go for 5 minutes break. Okay, we will briefly go through this example. You have to make sure you complete this example and submit to 9 times. Okay, so this is the star question of today. Also help you to score well in your final exam. I will just briefly go through. This is exactly the same example I have mentioned just now. It is a level control system. Your output is the H. You will measure this using the LT, means this is a level transmitted. So if the transmitter is used, then you'll be having the H now become your measured variable, HM. Okay, then you can see the signal become this solid line to become dotted line, indicates it is actually electrical signal, for example, milliampere. Your controller having the input and output both in milliampere, electrical signal. So from here, measured variable, this is the controller where they will compare your measured variable with the set point. So you'll be having this one going in, which is your HSP, measured variable. Okay, IP stand for current pneumatic means they change the signal from, so this one is actually transducer. So transducer change the signal from current to pneumatic so that the pressure can be used to adjust the opening of this Q2, either to increase the Q2 or reduce the Q2. Okay, so the one having the control valve is this one. You'll be having your GP over the output over the input, which is your Q2. So this is your GP. Your GD will be output over Q1. Okay, why in capital? Because later on you have to change everything to transfer function. Deviation variable, then you Laplace transform both sides, you will change everything to capital. So the one having the control valve will be GP. So this one will with control valve. Okay, like this. So this is your Q2. So this one will be your GP. This will categorize as disturbance. Okay, so consider a liquid level control system. So if you want to indicate this using the block diagram, it will be this. Your process. So this have some this one have some error. This whole thing should be placed here. So the corrected version will be, you'll be having your GP, okay, summation block plus. So this one will be your GD. The input of your GD is D. Okay, so why in prime form? So just now I use the capital, like this example, maybe they use Q2 minus Q2S using the Q2 prime. So this is the deviation variable. So you have to introduce your deviation variable. Either you are using the capital or either you are using the prime. Like this example, they are using the prime to indicate the deviation variable. That's why you can see everything in prime. Okay. So the previous example I have demonstrated just now, I actually used the Q2 only, the capital Q2. So this example, they use a prime to indicate it is unsteady state minus the steady state. So the correction over here is only to move the whole thing over here after this GP. So after this GP, something like this. Then the front one will be your GV, then your GIP. GIP means for transducer. So this one, transducer. This is valve. Okay, then this one will be your controller GC. And then there will be summation block. Negative means negative feedback. So from here all the way go to the back, you'll be having your output H prime. They use all the deviation using the clamp to indicate deviation. So the one going in will be your another transmitter over here. So you will complete this exactly the same km. Then the one going in is H prime SP. Okay, so here have another transmitter km. Initially is H prime. It will be converted to electrical signal to become H prime measured variable. Okay, so this one. The corrections here is only move this one after the GP. It is not here. Okay, so consider the liquid level control system shown in this figure below. The liquid level is measured and the level transmitted healthy. Change the signal from the solid line into the electrical signal, milliampere. And then you can control the H inside the tank by adjusting the Q2. So your Q2 will be your manipulated variable. That's why you have the H over the Q2 as your process transfer function. And this is the one by default Q3 equals to H over the R. So generate the process and disturbance channel function I have derived just now already. So please repeat again. Finally, represent them in the Kp over tau s plus 1. Just now we have derived something like this. So Kp over tau s plus 1. Okay, so this is one of the example for you to try and complete this one so that you can score during your final exam. So generate the control block diagram of this liquid level control system, assuming level transmitter control valve have negligible dynamics and proportional only controller have been used. Okay, They mention this if negligible dynamics, meaning that you'll be having your GV equivalent to only the gain, so kV. If this is GIP, transfer function for the transducer, it will just KIP, just the gain. Only has gain in the transfer function, just like this one. Because they say negligible dynamics, means you only have gain. Only have gain. Means the transfer function will be just represented using the gain of the transducer, the gain of the valve. So generate a control block diagram we have generated just now already. So generate the closed loop transfer function, which you are using this one. Okay, we go through the steps briefly. So unsteady state we have derived. Then we will having the unsteady state minus the steady state. We indicate which one having the control valve, Q2. Therefore, when you have the final equation like this one, you will be highlighting this Q2 and put it here with control valve. If it will control valve means you'll be having your H prime S over Q2 prime S as your GP. Okay, so this one please take note. Just like you having this as your GP and it is the same, right? Okay, same. So this one is your GP. So this one, Q1 disturbance. So Q1 disturbance means this will be your GD. Okay. Okay, thus we obtain the transfer function for the GP and also for the GD. And then solution B. So what they ask for the B? They ask you to generate a block diagram where you already generate. We'll be having this one as your answer. Okay. So if you have this already, they say this is a proportional controller, which means your GC is only having KC. So your GC equation for the controller will be covered, I think next week or next 2 weeks. So you'll be having KC 1 plus 1 over TI plus TD. Okay, as I think this is the equation. If I'm not mistaken, something like this. So if let's say it is a proportional controller, then your GC will be GC. So this one is for proportional controller, where your transfer function of GC will be just KC. So this one will be just KC. And these two that have mentioned negligible dynamics. So that's why you're having only the gain. So this is transducer. This is valve. So the arrangement is standard. You every time having your process transfer function, then transmitter to measure the level compared to the set point. Okay, and then the controller will ask the transducer to do something. They will ask the valve, final control element. Why you need the transducer over here? It is because of your valve cannot understand milliampere. That's why you need the transducer to convert the signal from milliampere to pneumatic signal transducer. Then only the valve can understand the pressure signal and adjust the Q2 go into your GP. Then the other one here will be, what is your input for this? D equals to your disturbance. So your disturbance is Q1. So here everything in capital, so Q1 prime. Okay, that's why I put this is the input. Okay, so this is 6B. This is just derivation to get the simplified version and represent, okay, if let's say it can be represented using this KOL, then you can further simplify. This one will be KOL over tau S plus 1 plus KOL. Means they represent the whole thing of this one equivalent to KOL. So this one also KOL. So we'll be having KOL over tau S plus, so this one, okay, sorry. Remember this one have to equals to 1. So you divide the whole thing by like this one, right? So Kc, Kip, Kv, Kp, Km divide by 1 plus Kc, Kip, Kv, Kp, Km over how over 1 plus, because this whole thing should be equivalent. So you have to divide every term with this pink color. It is because of this term must be equivalent to 1, just like k over tau s plus 1. This one is not in 1. You have to convert this into 1 by dividing the whole thing with the same term. So 1 plus Kc, Kip, Kv, Kp, Kf. The rest also divide with this same term. Kp, Km. Then only then this one will become 1. Okay, so let's say this is represented using the KOL. So you'll be having KOL over 1 plus KOL over tau over KOL plus 1. The S is missing. Ding, 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 ding. Okay, so simple calculation, go through this one. The one I need to highlight over here is what is the set, when a set point is given, they will mention a unit step change. Okay, unit step change means you'll be having the m equivalent to 1. If it's just a step change, then you will be having a magnitude of m. Okay, so if let's say this is introduced to the HSP, you will multiply or move this term to right. Okay, sorry, my line. Okay, is it still recording? Okay. So let me finish my line. It's not stable. Okay, please go through this example. Make sure you can do. So I have mentioned many times already, right? Means important. So this is the offset. You have learned this offset terminology during your lab already. Offset means the final steady state value and the set point. The gap in between will call as the set point, offset. So please make sure you go through this example, derive and submit to my times. Okay. We will talk more about final exam during our last session today, 6 o'clock. So you have few things to take note. One is, please go through your test questions, the solution provided earlier on. Go through the scope of the final exam. Okay, and then go through this example. It's recorded. So please make sure you download the videos for these 2 weeks, because my last day will be Friday. I'm afraid that they will remove my account, then you cannot access to all the videos. Okay, you can download the videos, right? Let me know whether you can download the videos from here. Okay, you try to download and let me know. Class right, Alvin, maybe you let me know whether you're all able to download the videos, because this Friday they will remove my account. Then all the recordings will be gone. Okay, and also go to backup your Telegram. All the handwritten notes I've shared early. So many messages. So if I'm too fast, you refer back to the recording, what you have to take note. The Telegram, because the new group will be created between you and the new module leader. So I will delete everything in the previous group. But before I delete, I already mentioned you go to backup. Means Telegram can be easily save all the messages. You just have to go there and download everything from your Telegram. So I will delete everything by this weekend. So everyone is here. I hope the message is clear. And then the recording, try to download, whether you all can download or not. If no, then you have to let me know. Or else I will assume everyone is okay, because Friday they will remove everything. Okay, so try the last example of today's lecture. And the lecture 11 and tutorial 11, they are very important, because in your final, there are 2 questions from that. You have to know how to calculate the standard deviation as well. Okay, we will cover more examples of today's topic at 6 o'clock. you have plenty of time before 6 o'clock. If you have no class, please complete this and submit to 9 times. I have written all the mark lab reports already. Go through the comments. I have put plenty of comments over there for your improvement for the coming semester. For the lab reports, how can you actually have a better lab report written? Okay, other than that, I think I have covered majority of the important announcement already. So if I overlook, maybe I will mention again at 6 o'clock. So that's all for this section. So 6 o'clock, please come for the last section online also. We will cover the tutorial of this and also the scope of the final exam. So important here will be you have to make sure lecture 11 and tutorial 11. So this one will be in final. There will be 2 questions. Okay, and use calculator, perform standard deviations, and also use calculator to actually solving something A plus B, A over the B plus C, and so on, the one involving solve. Okay, don't rearrange the equation to get the answer. Try to use your calculator, the solve function, the alpha x, remember that one? Okay, so this is important announcement. Second, the lab reports. Okay, third, FE scopes. Fourth, download recordings and Telegram or handwritten notes by this weekend. I think recording have to be earlier lah, by this Friday. So if you can do it now, today is our last session already. Night time, you go to download everything and keep for yourself. Don't share to your junior, don't share to other lecturers. So this one is for your usage, for your revision. Other than that, then the last one for this one will be complete last example of today lecture and submit. Okay, then the scope, I think we will focus more during the 6 o'clock session. So that's all for today. Thank you very much. Stop sharing.